In this video, we are going to discuss about how to utilize graph theory for solving network using nodal analysis. For that, let's develop generalized expression for node voltage using generalized representation of electrical network elements. So as we discussed in mesh analysis topic, let's consider kth branch of network which contains series combination of source voltage and impedance, and across this combination we can have a current source that is represented by ISK. So IBK represents kth branch current, ISK represent kth branch current source, ZBK represent impedance of branch K, VSK is kth branch current source, VBK is voltage across branch K. So from figure, this initial part is exactly similar to that of the things which we discussed in mesh analysis topic. So from this figure, VBK is equal to VSK plus ZBK IK. What is IK? IK is IBK minus ISK. Substituting that one, we can write down VBK is equal to VSK plus ZBK IBK minus ZBK ISK. From here, we can find out the equation for ZBK IBK. So ZBK IBK become VBK plus ZBK ISK minus VSK. From here, what is IBK? IBK is ZBK inverse, that is 1 by ZBK into VBK plus ZBK by ZBK will come, that will cancel. So remaining part is ISK only minus 1 by ZBK VSK. What is reciprocal of impedance? It is admittance. So this can be represented as YBK VBK plus ISK minus YBK VSK. So IB1 is equal to YB1 VB1 plus IS1 minus YB1 VS1. And finally, IBN is equal to YBN VBN plus ISN minus YBN VSN. Now we can represent this equation, this set of equation in matrix form like this. IB is equal to YB, this is admittance matrix, and this is branch voltage matrix, plus IS is the source current matrix, minus again admittance matrix minus YB into VS source voltage matrix. Let it be equation number 1. Here IB can be represented in this way. It is a column matrix, IB1, IB2, etc. IBN, where n is number of branches here. If n is 6, the size of this matrix is 6 by 1. And similar to ZB in mesh analysis topic, here YB is known as branch admittance matrix. YB matrix contains only diagonal entries. YB1, YB2, YB3, etc. YBN are the diagonal entries. All of diagonal entries are zeros. And similarly, VB is branch voltage matrix. If we can have 6 branches, the size of this branch voltage matrix is 6 by 1. Similarly, source voltage matrix, it is again VS1, VS2, etc. VSN 6 by 1. So if we are taking number of branches as 6, its size is 6 by 1. Similarly, IS is the source current matrix. Its size is also n by 1. If we are taking 6 branches, its size is 6 by 1. Now we are pre-multiply equation number 1 with A matrix in both sides. Both sides of this equation we are pre-multiplying with A matrix, that is reduced incident matrix. So the equation become A into IB is equal to A into YB VB plus A into IS minus A into YB VS, like this. Let it be equation number 2. We know A into IB is KCL equation, its value is 0. And also we know the relationship between node voltage and branch voltages like this. Branch voltage is equal to A transpose into node voltage. Now this part is 0. This we can represent in this manner: A, YB, A transpose Vn, like this. So this matrix, that is multiplication of A into YB into A transpose, that is a square matrix. That we can call it as node admittance matrix Yn. And this matrix size is number of node minus 1 by number of node minus 1, and this is Vn plus A into Is minus A into YB Vs. So this square matrix can be call it as node admittance matrix. It is represented by Yn. Now we can state this part, that is Yn Vn in one part of the equation, and remaining part we can move into right hand side. Now the equation become node admittance matrix into Vn gives AYBVS minus AIS. From here we can easily find out node voltage matrix, which is equal to Yn inverse AYBVS minus Yn inverse AIS. This gives a set of node voltages. Now let's see one simple problem. Draw the graph of the given network and find out the following. Here you need to determine A matrix, ZB matrix and YB matrix. What is ZB matrix? Branch impedance matrix. And YB matrix is branch admittance matrix. Yn matrix. What is Yn matrix? Node admittance matrix. And Vs and Is. What is Vs? Source voltage matrix, source current matrix, and Vn node voltage matrix. That you can easily find out by means of this equation. If you know all these things, you can just substitute those things in this equation and you can find out that one. So that I am giving to you as homework. So first of all, let's draw the graph of the network. For that you need to identify number of nodes. Here it is already marked, number of nodes is 4. You can mark number of nodes. And passive elements and voltage source, you can replace it by single line, so line segment. So that is already known to you. And current source is open circuited. So like this you can complete the graph of this given network. So next thing is you need to find out reduced incident matrix. How to find out reduced incident matrix? Corresponding to node 1, what are the branches incidents to node 1? 1, 2 and 3. From node 1 all these branches are leaving. So leaving away current is usually taken as positive, and the branches which is not incidence to node 1 is taken as 0. Similarly, corresponding to node 2, what are the branches incidence? 2, 4 and 5. Corresponding to 2, 4 and 5 entries are the remaining entries are zeros. What are the leaving branches? 4 and 5 are leaving, so their sign is positive. Corresponding to second branch, the current is entering towards this node 2, so its direction is minus, its sign is minus. And considering third node, the incident branches are 3, 5 and 6. Entry will be there corresponding to that one. Remaining entries are zeros. Corresponding to 1, 2 and 4, the entries are zeros. Here third branch and fifth branch are incoming currents, incoming towards node 3. So corresponding to 3 and 5, its sign is negative, and for 6 it's leaving, so its sign is +1. So this is the reduced incident matrix. Then this is the new thing to you. So ZB, next we need to find out ZB matrix and YB matrix. YB matrix is inverse of ZB matrix. So first of all, let's see how to build ZB matrix. In order to build ZB matrix, you need to remember these things. ZB contains only diagonal elements. Off diagonal entries are zeros. So corresponding to first branch, what is the impedance? The first branch impedance is 1. So that is I already marked. So corresponding to branch 1, the impedance is, or the resistance value is 1 ohm. That is diagonal entry. Remaining entries are 0. Let's see the second entry. Second branch, what is the impedance? 5 ohm. So corresponding to 2 by 2 elements, that is the diagonal entry, you need to mark 5. Remaining entries are zeros, like this. Similarly, what is third entry? This is the third entry. In third branch, what is the impedance? 6 ohm. So 6 ohm you need to mark here, like this. All the other entries are off diagonal entries are 0. Likewise you need to complete. Which one is the fourth branch? This is the fourth branch. In fourth branch, what is the impedance? 4 ohm. So corresponding to 4 by 4, 4 ohm will come. Remaining are zeros. And what is the impedance corresponding to fifth elements? It is 7. That 7 you need to mark here as the 5 by 5 elements. This is 0. And finally, and this is also 0. And finally, what is the last element? 6th by 6th element. It is 6th branch impedance. It is coming as 2 ohm. So 6 by 6th entry is 2 ohm. So this is your ZB matrix. After finding out ZB matrix, you can easily find out YB matrix, branch admittance matrix. It is the reciprocal of ZB. As ZB is diagonal matrix, we can easily find out YB. Diagonal entries just inverse gives YB matrix. So this is 1, this is 1 by 5, this is 1 by 6, this is 1 by 4, this is 1 by 7, and this is 1 by 2. All other entries are zeros. All these entries are zeros. So you need to mark in this manner. Okay, anyway, this is fully zero. Now let's see voltage source matrix. So what is the impedance corresponding? Is there any voltage source in branch 1? There is no voltage source in branch 1. Is there any voltage source in branch 2? Yes, there is a voltage source in branch 2. So when we are considering this arrow, which terminals we are seeing first? So it is plus 2 volt. So its sign is plus 2 volt. So it is decided based on the direction, assumed direction of branch current. Here this arrow is toward this one. So here we are seeing these positive terminals. So the polarity of this voltage source is taken as 2 volt, like this. No need of putting volt. Next, there is no voltage source in branch 3. In branch 4 also no voltage source. Branch 5 also no voltage source. And branch 6 also no voltage source. So all entries are zeros. Similarly, when we are considering this circuit, in branch 1 there is no current source, branch 2 there is no current source, branch 3 there is no current source, 4, 5 there is no current source, only current source is available in branch 6. Here the polarity is upward, here current is downward. So this current source is negative minus 2 ampere. 0, 0, 0. Last one is minus 2 ampere. So in this way you can find out the different matrices required for obtaining node voltage equation. So next we need to find out Yn inverse. Yn, what is Yn? A into Yb A transpose. So I am giving that work also to you as a homework. So this also you need to do as a homework. So Yn you can find out in this way: A, Yb, A transpose. A is known to us, Yb is known to us. You just multiply these matrices and find out the answer. From this problem, it is very clear that even though we discussed the generalized element representation, elements may contain impedance alone, elements may contain the combination of current source and impedance, elements may contain a combination of resistance and voltage source, elements may contain the combination of resistor, voltage source and current source. So sometimes current source may not be there, sometimes voltage source may not be there. This type of situation may come into picture. And regarding the sign of voltage source and current source vector or matrices, voltage source vector is positive if branch current enters positive terminals of voltage source in that branch. Otherwise, it is negative. If no current source is available in that branch, that entry is taken as 0. And similarly for voltage source, if voltage source is not there for a particular branch, then that entry is taken as 0. The elements in current source vectors are positive if the direction of branch current and current source attached to that branch are same direction. So these are the points you need to remember while writing voltage source matrix and current source matrices. There is one more homework to you. Here you need to derive the equation for node voltage, considering if source current direction in figure is opposite to the shown direction. That is, this is the figure which represents generalized network elements or branches. Here instead of this downward current direction, you need to take it as opposite, that is upward current direction, and do the derivation. So that is the second work.